In this video, I will talk about how to formulate a maximum flow linear programming problem in a network. In some applications, the value associated with the arc in a network represents the capacity that limits the quantity of the flow through the arc. We want to find a way to transport the maximum amount of flow from a starting point through the entire network to a terminal point. The starting point is called the source. The terminal point is called the sink. This problem is called the maximum flow problem. Let's check an example. Suppose a water treatment plant wants to pump the maximum amount of water via pipelines from source node S to sink node T. The water supply network is shown here. For example, from node S to node A, the capacity is 6 million gallons of water per day. From node A to node B, the capacity is 2 million gallons per day, and so on. How should we formulate this problem as a linear programming problem? We can define the following decision variables. Xij is the number of million gallons of water per day that passes through arc ij. In order to maintain the balance of the flow in the network, we assume that water is finally pumped from the terminal node back to the source node. Because it is not real, we call this arc an artificial arc. It is denoted by XTS. We want to maximize the amount of water flowing through this arc, so this is the objective function. We have a capacity constraint for each arc. The flow through each arc should be greater than or equal to 0, but less than or equal to its capacity. For example, XSA is greater than or equal to 0, but less than or equal to 6. XSC is greater than or equal to 0, but less than or equal to 5, and so on. For the artificial arc, it should only be greater than or equal to 0. Also, we have a balance constraint for each node. That means the flow into a node should be equal to the flow out of the node. For example, XTS is equal to XSA plus XSC. XSA is equal to XAB plus XAD, and so on. Okay, this is a complete linear programming formulation for the maximization flow problem in a network. Thanks for watching.